So we're going to learn about Vsepr theory. And Vsepr theory is just a fancy name for saying geometry. So it stands for Valence shell electron pair repulsion. And we know that when electrons are nearby each other, they're both negatively charged, they're going to repel each other. The terminal atoms move far away from one another, and this results in a distinctive geometric shape, just like yesterday with your strings. As you're trying to move them as far away from each other as possible, you end up with a specific shape. All right, there's a stepwise process to do this. We're going to learn that, and then we're going to look at a bunch of molecules to figure out what the correct geometry is, and then you're going to draw them. So the most important thing in doing this is that you draw the structure correctly. So we learned how to do that the last 2 lectures. We practiced structure drawing. You have your note card on how to draw structures correctly. And then once you draw them, what do you need to do? Check. No. So let's remember, not effective bonds. What do you have to check after you draw a structure? Formal charge. Oh, yes. Yes, Kirsten, sorry. I was thinking, what is she saying? But formal charge, yes, the calculation, given minus used, given minus used. Yes, true. Formal charge. Yeah, see, my technique stuck with you. So you have to draw your structure, check formal charge, and then you're going to do this next step. So I like to use the word domains instead of charge clouds. You will see both. So if you use your 5 to 5 book, you may see charge clouds in there or domains. You'll see them in a variety of ways, but they mean the same thing. So what you do is you count the number of domains, bonds, and lone pairs around the central atom. Each item in this list is a single domain. So domains are a single bond. So carbon to carbon, this is one domain. Carbon double bonded to carbon, this is one domain. Carbon triple bonded to carbon, this is one domain. You might want to say it's one domain, 2 domains, 3 domains, but that's not how it works. It just means where is that molecule's stretching across to bond to the other one. So this is one domain, this is one domain, and one domain. Everybody see that? We don't count them separately. And then a lone pair of electrons. So if I have oxygen and I have 2 lone pairs of electrons, this counts as one domain. And then this counts as one domain. So how many domains are on that oxygen? 2 and not 4. Understand? And then this last one is talking about a single unpaired electron. This is called a radical. You will not see that in this course, okay? So if you look here, you're not counting this as 1 and 2. This would just be one single domain, but you're not going to see that. It's just the rules for this. Any questions? All right, each of these is considered to be one bond. So we're going to count bonding domains and non-bonding domains. Those are going to be separate. So you have to be able to identify both. So a bonding domain is literally anything that's bonded. So it could be a single bond, a double bond, or a triple bond. Counts as a bonding domain. A non-bonding domain is a lone pair of electrons. It could be that radical, but we're not using it. So if I give you this counts as a domain, this would count as a domain, and this would count as a domain. See it? So these would be 2 non-bonding, this would be 1 bonding. We'll do this just on one molecule though overall. All right, so you are going to have to predict the shapes of all molecules that you draw, and you have to know all of the geometries by name, and you must know all their bond angles. So tomorrow's Quizlet, are you listening? Your Quizlet tomorrow is that you have 13 note cards made with the geometry name and the bond angle on the front, and on the back are your bonding and non-bonding. I'm going to show you what I mean in a moment. So here are all of your geometries. They're listed for you. You just have to make the note cards appropriately. So it's unfortunate, but you do have to memorize all of this. But you can think of it sort of like that's easy because it's not complex chemistry. The structure drawing is kind of hard, but after that, you should be able to draw your structures, and then you literally just memorize these, and then you can answer the questions about them.
memorize every single thing about them?
Yes. Unfortunately, you do. So we will do it for this exam, and then we really don't touch too much on geometry the rest of the year. We'll do it a little bit with intermolecular forces and polarity, but eventually we'll leave it. And then what you'll do is you'll keep these note cards, and when the AP exam comes in about April, I give you almost a month to review and we practice it all. You'll take those note cards back out and you'll study them in preparation for the AP exam. And usually I see the morning of the AP exam, someone has their note cards out and everybody just reviews them real fast, and they are there. They're definitely going to be on your exam. Yep.
We have to know all these by tomorrow.
So when's your quiz? So Tuesday you have to know them all by. Tomorrow I just want the note cards in class so that I know that you're
That's our quiz.
preparing. Yeah, your Quizlet grade is just going to show me the note cards.
Oh.
No, Quizlet grade is just show me your note cards tomorrow. So I wrote that up there, note cards. Just show me your note cards, and then that way I know that you're prepared to study and we're not waiting until Monday night to do them all, okay? So we're going to write this all down. So again, the front of the note card should have just the bonding and non-bonding information, so columns 2 and 3. And then the other side should have the name of the geometry, column 1 and column 4. 2 and 3, 1 and 4. Okay, and you'll see why once I start this. All right, so here's how this works. We're going to do domains. So everybody has their sheet. So you're going to look at your sheet and you're going to follow with me. How many? We're going to do it only on the central atom because the central atom is like your knot, right? This knot is the central atom. These were my 4 hydrogens on the outside, right? So I'm not doing geometry on a hydrogen. I'm doing geometry on the central knot. Like when you took your string models yesterday, you were moving them, and the knot was really where you were looking at where the geometry was. So you do geometry from the central atom. So on the central atom, I have 1 domain, 2 domains. Are there any non-bonding? Lone pairs are non-bonding. There are no lone pairs on the central atom. I have 2 bonding domains, 0 non-bonding domains. So which one does that match? Look at this. Find 2 bonding and 0 non-bonding. Say it. Linear. What's the bond angle? 180 degrees. This is literally what you do. You draw your structure, you count your domains, bonding and non-bonding, and then in your head, you have trapped all these 13 different geometries and their bond angles. So 2 bonds, no non-bondings, and the shape is linear, and the angle is 180. Does that make sense? All right, next one. How many domains do we have? 3 what? 3 bonding and 0 non-bonding. So what's this one? Yeah, this one's a tricky word to say. So everybody say it with me. Trigonal. Ready? Trigonal. Say it again. Trigonal. Because you want to say trigonal, but it's not. It's trigonal. So this one is trigonal planar. And the bond angles here are 120. So this was your flat planar one that you did yesterday, the 3 knots, right? We just held them flat in the plane, nothing behind, nothing in front. And so the bond angle here is 120 degrees. Next one. So how many bonding, how many non-bonding?
2 bonding.
2 bonding. Here they are. 1, 2.
1 non-bonding.
1 non-bonding because nitrogen's my central atom. So you go and look. It's bent, right? And its bond angle here is 120. Take a look on your sheet and go down a few to the other bent one. Do you see that one?
Yeah.
The other bent geometry has a different bond angle. It's less than 109. Why would that occur? This one is here, whereas water, I'll draw it the same way, this bond angle is less than 109. Why do you think that happens? Yeah.
Because in that belt one, there are 2 domains of non-bonding electrons, and they want more space, so they push the 2 bonds closer together.
Right. So these electron repulsion is creating more repulsion and pushing these bond angles closer together. And remember that your lone pair of electrons are sitting closer to the atom because they're not being pulled away by another atom, right? So they're just sitting here kind of waiting. All right, the next one. How many domains? 4 bonding, 0 non-bonding. This is the one that we did. This is this structure, right? So not 90 degrees is a tetrahedral, And your bond angles are 109.5. On your sheet, it says 109.47. We don't need to get that specific, but 109.5 is appropriate, okay? Next. Okay, look at it, say it. How many domains?
3
Three bonding,
1 non-bonding.
one non-bonding. So what is that?
Trigonal Pyramidal.
Yep. So try to say that one again.
Trigonal.
Nope, we did the trigonal one. We said is not trigonal. Trigonal,
Right here in the middle.
trigonal pyramidal, or on yours it says trigonal. What was it?
5 here.
Yeah. So trigonal pyramidal, or what they also gave you here, is acceptable. So trigonal pyramidal, you end up with a lone pair with a tripod. So it's literally a tripod sitting all going down. So these little legs are going down. Maybe I'll wedge those so you can see those are different. And this is like this. And then you have a lone pair sitting at the top of the molecule, pushing those little legs down. So the bond angle here, 107.3, but you're just going to follow what you have on this. And this one is 1, 2, 3, 4. 3 bonding. Yours says pyramidal. Do you see that? And this one says trigonal pyramidal. I'll accept either. This comes directly from the AP curriculum, so I just printed up one of the resources that they give the AP teachers. So clearly, if you write pyramidal instead of trigonal pyramidal, it's acceptable to the curriculum. So you can write either or, and I would accept it. And then this would just be less than 109. You don't have to memorize 107.3. These are what your note cards will come from. This is where it will come from. All right, so we have how many domains? 2 bonding, 2 non-bonding, bent, and again, the bond angle here is less than 109 because we have the 2 lone pairs. All right, how many domains? 5 bonding, 0 non-bonding. Say this one. Good, Henry. Trigonal bipyramidal. Trigonal bipyramidal. Let's try to say it under your breath at least so that you don't say it wrong. Trigonal bipyramidal. Okay. All right, so we have 2 bond angles here. We have a 120 degree, so your top view is planar, and then your bond angles here are 90 degrees along the side view. Next one, how many, Gonzo?
5. 4. 1 lone and 4.
So 4 bonding and 1 non-bonding. So look at your sheet. 4 bonding, 1 non-bonding. Seesaw. They gave this 2 years ago on the exam. They gave a seesaw geometry, which I was like, I don't know that they would ever give these really hard ones. Oh, they did. The hard ones. So
Seesaw would be easier to remember. It's so much fun.
maybe. They're all so much fun to memorize, aren't they? All right, so seesaw, you have the top view with a lone pair here. 120 side view, 90. All right, how many? 3 bonding, 2 non-bonding. T-shaped. So you end up with a T-shape. Those 2 lone pairs are sitting on it. Bond angles are 90. Any questions so far? I'm kind of rapidly going through it now, but this is what you do. You draw your structure, and then you just count them. Yep.
So after we draw our structure, we have to count the bonds and stuff, and then figure out which one it is, and then redraw it the way it should look.
So are you saying redraw it for the T-shaped, for example? Is that what you're saying?
So, yeah.
Like say this example, this is how you would draw it after you checked formal charge. So if formal charge said that you should draw it some other way, you would draw it that way, but then you would predict geometry on your final structure. You don't redraw it.
Oh, I don't have to, so like that's my
That's
goal.
it. You can't possibly represent a 3-dimensional molecule on paper.
Oh.
I mean, in organic chem, you'll use your wedges and your dashes, but that's very rare that you'll see that. All right, so this one. How many bonding, how many non-bonding?
2 bonding.
Yep. And this one ends up being linear, right? And linear, you know anyway, is 180. So there's your bond angle. All right, this one we have 6 bonding, 0 non-bonding. You go and look it up. It's octahedral. This is the one that we did with the string models yesterday, right? You could see the 8 faces of the model. And so bond angles here are 90 because it was a T and then another T. Next one. 5 bonding, 1 non-bonding, square pyramidal. Say that under your breath. Square pyramidal. Square pyramidal. So you end up with 90 degrees on this one, less than 90 degrees. And then, how many bonding, how many non-bonding? 4 bonding, 2 non-bonding, square planar, and bond angles are 90 degrees. All right, so this is them all for the geometries. Literally, you make your note cards, you memorize them. Your structure drawing is truly what you need to be a master at. If you draw the structure incorrectly, you're going to get that wrong, then you're going to get your geometry wrong, and then you're going to get your bond angle wrong. So you need to make sure that your structure drawing is up to par, which we practiced for the last 2 days, so you should be okay.
So we're going to be asked with the bond then?
Yes.
On both?
Yeah. So your quiz Tuesday, I will have you draw structures. I will ask you the geometry on all the structures and ask you to give me the bond angles. It's so straightforward. And you're going to do it today. You'll see them.
So the quiz is going to be like all structures, right?
That's exactly right. All right, so if you have compounds with multiple central atoms, which is really, most molecules have more than one central atom. So think of the structure for blue dye. You guys saw that, right? That has lots of central type atoms, and the geometry kind of rearranges itself all over, and then all of a sudden this molecule has a specific shape, right? That's how that lock and key works, is that the molecule really is designed in a certain way. So if you have more than one central atom, you do geometry on all of them. So you'll have multiple geometries, but you do it the exact same process. So for example here, I have carbon 1, carbon 2, carbon 3, and they may ask you predict the geometry around carbon 2. And then you would have to determine this one is, what is this one? What's the geometry and bond angle?
Bonding, 0 non-bonding. 2 bonding.
Why? We just remembered single, doubles, and triples count as one domain. Right? If my arms are stretched like this because I'm a double-double or they're a single-single, my arms stay the same position. It's just my bond length shortens for the double or the triple, right? But I still stay in the same bond angle. So the domains still count only as one domain regardless of.
So C1 and C3 would have 3 bonding?
Right, so carbon 1 is 3, and that is trigonal planar. Carbon 2 is linear, because it has 2 bonding, 0 non-bonding. And what's carbon 3? Trigonal planar, because it has 3 bonding, 0 non-bonding. Get it?
Yeah.
Okay, so now we practice. Any questions so far? All right, so you are going to keep this sheet out. You're going to keep out your little note card about how to draw structures.